Up, dog. What's up, dog? Nothing much, Doug. How about you? This is the Nmap Basic Port Scan. In the previous room, Nmap Live Host Discovery, we covered the three steps of Nmap Scan, which is enumerate targets, discover live hosts, and reverse DNS lookup. And in this room, we will focus on the TCP Connect Port Scan, TCP Send Port Scan, and UDP Port Scan. Let's move on to Task 2. TCP Port Scan. An IP address specifies a host on the network. TCP and UDP ports identifies the network service running on that host. A service using a TCP and UDP ports to communicate over the network. For example, a HTTP server will be bind to TCP port 80 by default, and HTTPS will bind to TCP port 443 by default. There are only one service per port on a given address. In Nmap, the port can be open or closed. Open port means there is a service actively listening on the port. A closed port just means there is no service listening, but the port is reachable. In real life, this situation is a bit more complicated due to firewalls. So Nmap considered the following six states. We already talked about the open and closed port state. Now we're going to talk about the filter port state. This just means that the Nmap cannot tell. It is likely that the traffic has been blocked by the firewall. Next one, we have the unfiltered port state. This means that the port is reachable, but the scan type such as XScan cannot determine the state. Next one is open and filter. This means that the Nmap cannot determine whether the port is open or filtered. Lastly, close and filter. This means that Nmap cannot decide whether the port is closed or filtered. Okay, let's answer the questions below. First few questions require to do a little bit of searching, but you just need to search UDP port 53. This will tell you the port 53 runs on DNS by default. Again, with question 2, a little research. Port 22 runs on SSH by default. How many port states? There are 6 different port states stated by Nmap. And last question, which port state is the most interesting to discover as a pen tester? Well, technically speaking, there's only 2, open and close, and the rest of them is due to some other situations where Nmap cannot determine what they are. But open port state is definitely one of the one we interest in the most. And move on to task 3, TCP flags. To understand how Nmap performs TCP-based scans, you need to understand how the TCP header, particularly in the TCP flags. These flags are the binary switch that tells the receiving system what kind of packet that is and how it should respond. These flags allow Nmap to manipulate the TCP packet in a specific way to identify port states without completing a full connection. And this is a TCP header. This is using a TCP header in RFC793. Some key fields here we're looking for is the source port for sure, the destination port. You'll have your sequence number, acknowledgement number, then the flags. In particular, there are a few TCP flags here that are pretty important. The first one being the urgent flag. It marks data as urgent TCP segment with the urgent flag is processed immediately without consideration of having to wait on previous sent TCP segments. Then you have the acknowledgement flag. This is used to confirm the receipt of packets. Next, we have the push flag. It tells TCP to deliver data immediately to the application. Then you have the reset flag. This is used to end connections or indicate a port is closed. Then you have the synchronize flag. You use it to initiate the connection, the first step in a three-way handshake. Lastly, you have the finish flag. This is used to end the connection. So from here, let's answer the questions below. What three letters represent a reset flag? Reset flag from the text above we know is the RST flag, so we just put down RST. Next, which flags needs to be set when you initiate the connection? Well, the first packet you always send to initialize will be the synchronized flags. So here we will put SYN for synchronized flag. Right, move on to task 4, TCP connect scan. And here we should start with a machine and the attack box first, just so we can have it loaded by the time we get to it. All right, what is TCP connect scan? TCP connect scan is the most straightforward type of TCP scan. It works by initiating and completing a full three-way handshake with the target port, just like any other normal connection attempted by other applications. This scan uses the OS system calls to let the OS do the heavy lifting. Well, how does it work? So you have you will send a SYN flag, which Nmap will send to the target port, and if the target responds with the SYN ACK, this tells us the port is open. Then you will send the acknowledgement to your target to complete the three-way handshake. And lastly, you finish the scan with the reset flag to end the connection. This is because Nmap does not want to actually connect, it just wants to confirm whether the port is open or closed. So when you're using TCP connect scan, you should see 4 different flags. And what is the difference between privileged user and unprivileged user? Well, unprivileged user can only use TCP connect scan, while the privileged user can use raw packets and other scans like SYN and ACK scan. Within the Wireshark observation, we can see that TCP will send packets with a synchronized flag to various ports to initialize the connection. From the traffic, we see that port 143 have complete the handshake, and the picture below it showed it end the connection once the Nmap confirmed the host is up. And here's the command we'll use for TCP connect scan. Some options we can use here with the commands are -F. This enables the fast mode, which only scan the 100 most common ports. And we have the -r. This can be added to scan the port in consecutive order instead of a random number. This will be the only TCP scan we learn in this room without needing a privileged user. And let's answer the question below. So launch the virtual machine, open the attack box, and execute nmap-st machine IP in the terminal. A new service has been installed on this virtual machine since the last scan, which port number was closed in the scan above, but is now open on the target virtual machine. So if we input the command nmap -lowercase s and capital T followed by the IP for the target, and from the scan result, I can see that port 110 did not show up the last scan, so this is new. So we'll put 110 as our answer. Next one is, what is Nmap's guess about the newly installed service? Well, beside it, we can see a service column, and the Nmap believe this is a POP3, which stands for Post Office Protocol 3. All right, let's move on to task 5, TCP SYN scan. So since this task has a new machine, let's just terminate the current one and start the new one for task 5. We should do that for probably every task that have a new machine, just to make sure that it works for our questions. So how does a SYN scan work? Well, the SYN scan requires you to be a privileged user in order to run it. It starts with the TCP three-way handshake, but it never completes it. What this means is you will make a scan more stealthy and faster. From this diagram, you will see that the target machine, our machine sends a target machine a TCP packet with a SYN flag to initialize the connection. If the port is open, you'll see the SYN-ACK flag coming back from the target machine. And then you cut it. You immediately respond with the reset flag to end the connection. And that's how you not complete the handshake. If the port is closed, it will just send you our reset flag back, so you know it's closed. Because there's no real connection, it's been established, making this less likely to be logged. It will be faster to scan, and you will be stealthier, especially against the intrusion detection system, the IDS. In Wireshark observation, we can see it started the same by sending SYN-PACK to various ports. And here you can see port 80 responded with the SYN-ACK flag, means the port 80 is open. And this is enough for Nmap to determine the port state. Thus, it cuts the connection with the reset flag. And the picture below just shows us the difference between a connect scan and a SYN scan. And here's the command we will use. We have to use sudo because it requires you to be a privileged user. Okay, with that, we have enough to answer the questions below. Launch the virtual machine. Some new server software have been installed since the last time we scanned it. On the attack box, the terminal to execute nmap -lower s and capital S with the machine IP. What is the new open port? Okay, once we type the command and hit enter, we will compare the results between the table. Just be aware that when you just started the machine, the service takes a little bit to load up, so you may not see the results right away. So just be patient. But once that is done, we can see there are a few more than one new open port. But the answer is in 4 numbers, so it must be the 6667. Next, what is Nmap's guess of the service name? Well, here it says in the service column, it should be the IRC. Okay, next task 6, UDP scan. What is it? Well, UDP is a connectionless protocol. When you're scanning with UDP, there's no handshakes, which means there's no connection, which makes it more stealthy. But some of the downside with the UDP, since there is no connection, we don't know if UDP port would actually respond. But if the port is closed, we will receive the ICMP port unreachable error. So I guess it's a different, we're looking for different response based on the protocols. In the Wireshark observation, we can see that all the port that is closed will return a destination unreachable error. Again, this scan required to be privileged user, and we have enough to answer the question below. Launch the virtual machine on the tab box. Use the terminal to execute nmap -s U -f -v with the machine IP. A new service has been installed since the last scan. What is the UDP port that is now open? Let's type in the command. We want to type in the -F for fast mode and the v to get update as the scan progress. Then the IP address. You hit enter. Now we wait. Remember, this will take a while because Nmap is waiting for each port to respond, and sometimes the port ghosts you, so we had to wait for the packet to time out essentially. However, once we get the result, there's only one new open port. So the answer will be 53. What is the service name according to Nmap? Well, Nmap thinks the service running on this port will be a domain. Okay, this can conclude task 6. Now task 7. tune the fine-tuning scope and performance. All right, let's break this down. Well, first start with the port selection. Here we can pick specific ports. So after dash P, we can choose the port we want by separating them with comma. The example shown here with the dash P 22, comma 80, comma 443. It just tells us that we want to scan for port 22, port 80, and port 443. And we can select the port range. Again, start with the start with the dash P followed by the range of ports you want to scan. Here we have dash P 1-1023. It just tells us that we want to scan from port 1 to port 1023. This is all inclusive. So another thing that tells us here is P 20-25. It just said we want to scan from port 20 to 25. So this will be 20, 21, 23, 24, 25. And if you want to select all 65,535 ports, you can simply use dash P dash. Some option we saw earlier, like using capital F for 100 most common port. Here you can use dash dash top dash port 10 for the 10 most common ports. After selecting ports, we can choose how stealthy and fast we want for the scan. So here you can choose the preset timing value that is shown on the table here. And we can see T0 is the most stealthy one because you only send one probe every 5 minutes. And T5 is insane mode. This is fast, but you're also risking packet loss and detection. It's very, very noisy. You can also customize the packet rate control and to just tell us how many packets we want to send per second. So here we can use, example here, we can use the dash dash min dash rate 10. This just tell us we want to send at least 10 packets per second. Next up, we had the probing parallelization. This control how many probes Nmap sends simultaneously. More probe will result in a faster scan, but then it can also cause issue. This command dash dash max dash parallelism 512 pushes Nmap to have at most 512 probe in a parallel. All right, we have enough for the questions below. So start with what is the option to scan all the TCP port between 5000 and 5500. For port range, we will use the dash P followed by the starting port and dash to the last port. So here you will be dash P 5000 dash 5500. How can you ensure that Nmap will run at least 64 probes in a parallel? Well, we can use the parallelism command. So we will type in dash dash min dash parallelism equals 64 to set the probes. And last one, what option would you add to make Nmap very slow and paranoid? I mean, from the list above, we can see that T0, which is the stealthiest one, and it's very slow, will be the one we want to choose. Last test, the summary. Here are the scans we cover in this room, along with some of the options, and just to make sure you get yourself familiar with them, because in the future we will use them more. And we just complete the room, Nmap basic port scan. The next room will be the Nmap advanced port scan, so be ready, stay tuned, and I will see you next time. Peace.